R3 to determine the voltage values VR1, VR2, VR3. So I into R1. I is the 1, R1 is the 10. So 1 into 10, 10 volts. VR2 is equals to I into R2. 1 into 20, 20 volts. Similarly, VR3 is equals to I into R3. 1 into 30, that implies we are getting the value as 30 volts. So this is for the series connection to determine the individual voltage drop across each resistor. So in the second problem we discussed about the three resistors are connected in series and parallel. So only we want to calculate the current only. So in this case, only we want to determine the current in case of series connection as well as a parallel connection. So first we solve for the series connection. So the total resistance in series connection is nothing but they are connected in series. Because of that reason, we are adding the all resistors. So means 10 plus 20 plus 30. That implies we are getting the value as 60. To determine the current value, I is equal to V by R total. V is the 240 by 64 amps. We are getting in a series connection. But in case of parallel connection, so the current is divisible. So because of that reason, there are three currents will be there. So the three currents will be we find out. Then we can simplify the problem. So there are two methods we have followed. So first method, direct we find out the current values of I1, I2, I3. Because there are three resistors is there. Because of that reason, the current is divided into three portions. That is the one method. Another alternative method, so parallel connection will be simplified into single equivalent circuit. It is nothing but we determine the 1 by R equivalent is equal to 1 by 10 plus 1 by 20 plus 1 by 30. So if we are simplified, R total we are getting as a 60 by 11. So that value also we can substitute in the equation. I is equal to V by R. We already given in the problem, that is the 240 by 60 by 11 is equal to we are getting the value as 44. This is the one method. Second alternative method, so first we determine the individual current of I1, I2, I3. Already we know the basic formula is equal to V by R. Instead of R, we can take the R1, R2, R3. V is constant because it is a parallel circuit. Then we find out the current as 24, 12, 8. It is the summation of all current, that is the total current. So I is equal to I1, I2, I3. That implies we are getting the value as 44 amperes. This is another parallel method. Right? So up to this it is very simple. So by using of one formula, we are find out the total current in series circuit as well as parallel circuit. But in some cases, he asks about the individual current, only I1 current or I2 current. We want to find out with a given occur.
छोटा कुछ छोड़ डाले सेल नहीं आता है ना पेमेंट लेने का बड़ा क्वेश्चन नहीं कर सकता हूँ छोटा क्वेश्चन डाल देता पेमेंट ऑप्शन नहीं कर सकता हूँ गूगल वाले तुम लिखते हैं सार कंप्रेशन नहीं करना होती है इनको याद है इन सारी
We know that there is a summation of individual currents. IT is equals to I1, I2. But already we know that I1 is equal to what we can write V by R1. So instead of I2, what we can write here V by R2. Already we know the thing. The voltage is constant for both cases. Means across R1 resistor, the voltage is same. Across R2 resistor, the voltage is same. So here, the voltage is same. So if you are measuring in between these nodes, in between these two nodes, the voltage is constant. Voltage is constant. So that implies we can write as a V is equals to I1 R1. So just we are assuming V is equal to V1 is equals to V2. So V1 is voltage across the R1 resistor. V2 is the voltage across the R2 resistor. So that implies V is equal to V1 is equals to V2. So we can write this formula according to the parallel circuit. So just we are taking here, so we are removing, so just we are comparing the V1 is equals to V2. So already we know the V1 value. What is the V1 value here? V1 is equal to I1 R1 is equals to V2. Instead of V2 we can write as a I2 R2. I2 into R2. So we want to equivalent one current. So if you want to determine only I1 current, so what we can write here? I1. So R1 will be present, that will be moved to RHS side. So then what we are getting here? I2 R2 is already present by R1. So if you are separating currents and resistors, that implies I2 of R2 by R1. So this is a I1 current we want to determine. So substituting the value of I1 in I total. So I1 is equal to I2 of R2 by R1. So this value we are substituting in this equation. So if we are substituting that value in this equation, what we are getting here? I total is equals to, instead of I1 we can substitute as a I2 of R2 by R1 plus I2. So in this RHS side, in both one, the I2 is a common. So first we take I2 as a common. So I2 of R2 by R1, if there is nothing, 1 is present. So then we are taking the LCM. What is the LCM is here? R1 is a LCM. I2 of R2 plus R1 by R1 by R1. So that is equals to I total. Right? So I2 is equals to, we can write I total is equals to I2 of R2 by R1 plus 1. So we are taking the LCM as a R1. We are getting the value as I2 of I1 plus I2 by R1. So R1 plus R2 by R1. So we want to determine the I2 value. So I2 move to LHS side and I total move to RHS side. So then just we are interchanging the positions. Then the numerators, denominators also becomes changes. So then we can get the value as I2 is equals to R1 by R1 plus R2 into IT. So simple, remember the formula. To determine the currents in parallel circuits, we are taking as a equation as total current into opposite resistance by total resistance. So this is the formula we are using. So no need to remember all the simplification or equation. Just you should remember the formula to determine the currents in individual branch, not the total current. So here if you want to find out the I2 value, so first we find out the total current. So what is the total current flowing through the circuit? So that should be, we first determine. Then after we are substituting the values of opposite resistance and total resistance. So what is opposite resistance is here? So we want to determine the I2 value. So what is the I2 value? Opposite resistance, what is there? R1 is a opposite resistance. So then we are getting the value as opposite resistance is R1. Next, total resistance is nothing but summation of R1 and R2. So this formula will be very helpful while we are calculating the current values for individual resistances. Right? So that is a simplification we solved here. Right? So finally we are getting the value as I2 is equals to R1 by R1 plus R2 into I total. So if you solve one problem, we can easily understand the concept. So you can see here, this is a diagram, this is a circuit is given. What is the circuit is given? Find the magnitude of total current. Magnitude of total current through R1 and R2. Through R1 and R2. If 10 ohms, comma 20 ohms. R1 is a 10 ohms and R2 is a 20 ohms, and the voltage is a 50 volts. So this is our circuit. So problem is given. We want to find out the total currents through R1 and R2 when the resistance values as 10 ohms and 20 ohms, they are connected across the 50 volt source. So just we draw the circuit according to the given data. A voltage source is there. The value of voltage source is a 50. The value of voltage source is a 50 is here. This is a 50 volts. So R1 is given as a 10 ohms and R2 is given as a 20 ohms. So just we draw a circuit. What we are assuming, the total current is flowing through the voltage source. When it is reaches to this point, the current is divided into two portions. That is a I1 and I2. We are assuming as a I1 is across the flowing through the R1 resistor. I2 is flowing through the R2 resistor. So this is assumptions we are made here. So what the formulas we had derived in the previous session, to determine the currents, we have the one formula that is equals total current I total into opposite resistance by total resistance. This is the formula you should remember in case of parallel connection to determine the current value. So if it is parallel connection, series connection, so there is a need to find out the voltages. I am also explaining about the problems related to the series also. Right? So here, first we think about the parallel connection. Right? First, we determine the total current. Then only we can possible to determine the individual currents. Right? So we have the several methods. First, we can find out the I is equal to V by R. So instead of V, parallel connection, V is constant. Already R1 value is given as a 10. So then we can easily simplify V is equal to 20 by R1 is equal to 10. So 10 to just 20. So I is equal to 2 amperes. Right? So I'll find out this amount. So there is a change in the currents because it is a parallel connection. So actually we are getting as a 5 amperes. But in this case we have determined the value as a 2 amperes. So it is extremely wrong. So to determine the individual currents, there is a procedure we are followed here. So first we determine the R total, because in resistance parallel circuit the resistance will be decreases. Actually 10 plus 20, the value is a 30. That is for the series connection. But in case of parallel connection, the resistance value becomes decreases. So that point we should be remember. So first we determine the R equivalent. Already we know the formula for R equivalent. R equivalent is equal to 1 by 10 plus 1 by 20. So we take the LCM as a 20. So 10 to just plus 1. So 3 by 10, 20. So 3 by 20 value we are getting as a 1 by R total. But what is our value is needed? R total. So because of that reason, R2 is shifted into numerator, 1 is shifted into denominator. Similarly, 20 is shifted to numerator, 3 is shifted to denominator. So therefore, R total is equal to, we are getting the value as 20 by 3. So 3 is just 18. So 2 is remainder. So 2 is, if you are taking as a point, 20. So 6. So then 7. So 6.67 amperes, ohms, we are getting as a resistance value. So we are find out the resistance value, then we substitute in the equation. So I is equals to V by R. So instead of R, we are taking as a R total. So instead of T, we can we can take as a I total. So that implies, so 50 by 6.67, the value we are getting as a 7.5 amperes. So this is a total current we are obtain here. So next we want to find out the individual currents. So already we know the basic thing formula, the total current into opposite resistance by total resistance. So what is the total current is here? 7.5 is the total current. So to determine the I1 value. So this is the I1 value we want to find out. So the total current we are write as usually. So then what is the formula? Opposite resistance. What is opposite resistance is there? R2 is the opposite resistance. So we are substituting the opposite resistance as a 20 by summation of resistances. So there are two resistance will be there, that is equals to R1, R2. So that implies we are getting the value as 20 by 10 plus 20. So that is a 20 by 30 into 7.5. If we are simplified, we are getting the value as 5 amperes. Similarly, I2. So to find out I2 value, first we write down the total current into opposite resistance. What is opposite resistance is? R1 is the opposite resistance, and 10 by 10 plus 20. So this is a I2 current we want to find out. For example, if there are 3 resistors is there, additionally another resistor R3 is there. So this is a I3 current. If you want to find out I3 current, first I3 is equals to, we write as usual formula as I total into opposite resistances. So how many resistances opposite there? So across R3 there are R2 resistors are connected. So the product will be we are taking here is nothing but R1 R2 by total resistances R1 plus R2 plus R3. Right? So similarly, to find out the I1 value, so opposite resistances what are there? R2 and R3. So then the product of R2 and R3 we are taking here. So similarly, to find out R2 value, R1 and R3 by R1 plus R2 plus R3. So this is the method will be we are followed. So when the resistors are connected in parallel to determine the individual currents. But whenever we want to find out only the total current, so simply any one of method we can use. So that thing will be important. So while we are calculating the parallel connection. So for example, if it is a series connection, so just we are assuming it is a